So here's a type of question that you guys are going to see a lot. So we have these three functions, f of x, h of x, and g of x. And the question is which one of these is the original function, which one is the derivative, and which one is the second derivative. So what's the relationship between these three functions? So we got to remember back to the rules that we used, that we figured out from graphing. And we're just kind of going to skim over these and look at how they relate to these three functions to figure out the relationship between them. So let's just start and take a peek. Well, let's start with f of x. The first thing we notice about f of x is that it has a 0 over here. So I'm just gonna mark it out. Now we're gonna go ahead and look at the rest of the functions and see if there's anything special occurring at that 0. So g of x doesn't seem to have anything special happening, it's just simply increasing on that point. H of x, on the other hand, has a local maximum. So that right there tells us a lot. But let's just keep on looking to make sure we're not missing anything. The next point that we're going to look at is this point right here, where f of x has a local min. And as you can see there, g of x is changing signs, and so is h of x. So that's not that good of a point to look at, since it could tell you something, since this is local min, and we know that local mins occur when the derivative is changing sign from negative to positive. But let's keep on plotting points. Here's another good one. H of x here has a local min, and as you can see, f of x is changing sign, and g of x has a local maximum. And let's just look at one more. Let's just look at this point right here. G of x has a local min, and what is this? F of x seems to have an inflection point, and h of x doesn't really seem to be doing anything. So now let's kind of go and interpret these points that we looked at them, and any one of these will do. We're just going to kind of look back to the rules. So let's look at this first point, where f of x is changing sign, right, because it has a 0, and h of x has a local maximum. So if we look back to our rules, well, we know that if f prime of x changes sign from positive to negative, which is what's happening with f of x has a local maximum, which is what's happening with h of x. So from that right there, we can tell that h of x is the derivative, f of x is the derivative of h of x. So the derivative of h of x is f of x. Because if this was f of x and this is f prime of x, then it would make sense that when f of x has a local maximum, f prime of x is changing sign. So now let's look at this last point again, where once again, two things are happening, one with g of x and one with f of x. G of x has a local minimum, and f of x has a inflection point. So let's look at what we have here. And over here you can see when f of x has an inflection point, f prime of x has a local maximum and minimum. So right there we know that g of x is the derivative of f of x. The derivative of f of x is g of x. And once again, because our function has an inflection point, our function being f of x, the derivative has a local maximum or minimum, in this case minimum. So that's pretty much all we need to know to solve for which one is the function, which one's the derivative, and which one's the second derivative. I'm just going to copy what I had up top over here. We said that h prime of x is equal to f of x, and f prime of x is equal to g of x. So at this point, lots of people mess this up, the relationship, figuring out which one's the function. Well, if the derivative of f is g and the derivative of h is f, then from there we can say that g of x is the second derivative of h of x. Since to get from h to g, we take the derivative to find f, and then we got to take the derivative of f to find g. And from there, it'll make it a lot easier. G of x is our second derivative. And of what? G of x is the second derivative of h, so h is our function, leaving us with f of x as our first derivative. So honestly, when doing these types of problems, there are so many different ways to figure this out. You could look at the end behavior, seeing that h of x is approaching a slope the slope of the tangent of h of x is approaching 0, and as you can see, f of x is approaching 0 and is positive, and h of x has a positive, is still increasing on that interval, so we can tell from that that f of x is the derivative of h of x. And then from there you could say that since f of x is approaching is decreasing, approaching a tangent slope of 0, and g of x is negative, approaching 0, we can tell that g is the derivative of f. So many different ways, and you could look at all these points, and I think it would be really useful for you guys to kind of look at every single one of these points that I plotted out, even this one, and notice the behavior of all three functions and how they relate to each other, and really be comfortable with these rules, because that's really what's going to help you with these types of problems. So really memorize these rules, and I'm going to leave you with these rules, so you guys can pause the video, make sure you have these down, because these are really important for this chapter and for the rest of BC. And that's it.